Hello everyone, today is day 65 of solving a LeetCode question every day, and today I'm going to solve a lowest common ancestor in binary search tree. So given a binary search tree where all node values are unique and two nodes from the tree P and Q, return the lowest common ancestor of the two nodes. The lowest common ancestor between the two nodes P and Q is the lowest node in the tree T such that both P and Q are descendants. The ancestor is allowed to be a descendant of itself. All this line means right here is that the ancestor can also be either P or Q. So for example, P could be the ancestor and Q might be a descendant of it. So we're just saying that P is a descendant of itself. So in this example right here, P is 3, which is right here, Q is 8. So the lowest common ancestor is going to be the root node, which is 5. In this case, P is 3 and Q is 4, and this is kind of where we have that self-reference. So the output's going to be 3, since we can say that 3 is a descendant of itself and 4 is a descendant of 3. So this is the way I'm going to be looking at this problem. So first of all, we know that all nodes are unique. So that's for one. And second of all, we know that this is a binary search tree. So what we know about that is at every node, the left node is going to be, the left child node is going to be less than the parent node, and the right node is going to be greater than the parent node. So I guess based off this fact, at some point, so let me put it this way. At some point, P and Q are going to be in different subtrees. Like, for example, right here, at the we have an ancestor, and at the ancestor, then, they both go into different subtrees. And we can know when this happens by the fact that, by the property of the binary tree. So, we know that since, for example, here, we're at 5, and we know that 3 has to be in the left subtree, and 8 has to be in the right subtree. So at this specific node right here, we know that this must be the lowest common ancestor, since they go and split up into different subtrees. Now with this example, it's kind of the same thing. So we go into this tree right here, we have a 3. We know that the nodes have to be unique. So we know that at this root node right here, so we're looking at, we're looking at 3 and 4. So we're searching for P and Q. So 3 and 4 are both gonna be in the left subtree since they're both less than 5. So now we're at 3 here, and we know that 4 is gonna be at the right subtree, but we know that 3 can't appear again. So that means that the lowest common ancestor is gonna have to be this 3 right here, since P can be a descendant of itself, and we know that 4 is going to be here, so that's going to be the lowest common ancestor. So the general idea is that we want to find two cases. Either we're going to reach a point where P and Q are going to be in different subtrees, and once we reach that point, we know that that node is the lowest common ancestor, or we pretty much reach either P or Q. So let's say we reach P over here. Then if Q is a child of P, then we know that P is going to be the ancestor, or the lowest common ancestor. So this is how we can just do that. We're going to say current is equal to root, and while current. Now let's think about this. So we want to find when these subtrees split up. So, and we also want to make sure we're traversing the right way. So we can say if p.val is less than cur.value and q.val is less than current.value. So if the value of p is less than the current, and the value of q is less than the current, then we need to go to the left subtree, sorry. Because that means that p and q are somewhere in this left subtree. The other case would be that p dot value is greater than current dot value, and q dot value can be greater than current dot value. So now we know we need to go into the right subtree. So this code right here is basically looking for where the lowest common ancestor is, because for example here at 5 we know that p dot value and q dot value is both less than 5, so we go to this right subtree here. However, we reach this 3 now and we see that q dot value is greater than current dot value, but p dot value is actually equal to current dot value. So what we want to do in that case, so else, we just want to return current, since that's going to be the node we're looking for. So if I run that, accepted, submit that, accepted. So just to quickly go over this again, let's do it in this example. But so I mean, this is a really simple example, so you can see exactly how it works over here. So p dot value is going to be less than like the roots value, and q dot value is going to be greater than the roots value. So none of these conditions apply. So in that case, we can just return current, since that's going to be the lowest common ancestor. So yeah, that's the general idea behind this problem. The time complexity of this is going to be at most O of h, where h represents the height of the tree. And the space complexity of the solution is going to be constant, since we're not really storing like a list of anything. So yeah, that's the solution for the day.